Hi guys, this is Geometry Topic 9. We're going to talk about Lesson 1 from Topic 9, but first let's look at the overall topic. Topic 9 is all about coordinate geometry. So if you remember coordinate plane and coordinate points, those are the graphs that you learned in Algebra 1. So we will talk about geometry in a coordinate plane. So the essential question is, how can geometric relationships be proven by applying algebraic properties to geometric figures represented in the coordinate plane? So I greatly recommend going back to Algebra 1 and reviewing coordinate sections if you don't remember that. So we have 4 lessons total in this topic. We'll start with polygons on the coordinate plane. We'll start proving in lesson 2, and we'll also look at circles and parabolas. So it does get a little bit challenging. We will use these words like directrix, focus, and parabola. So let's look at lesson 1. Lesson 1 is about polygons and the coordinate plane. In this lesson, we'll be able to use the coordinate plane to analyze geometric figures. Let's start with explore and reason. Players place game pieces on the board shown and earn points from the attributes of the piece placed on the board. So you can see that the board has grid lines that resemble coordinate plane, and we see shapes that are on the lines, right? So we see the rules for the game. It says 1 point for a right angle, 2 points for a pair of parallel sides, and 3 points for the shortest parameter. So if you see the attributes, then you will get the points depending on the attributes. So part A, which game piece is worth the greatest total points? So you're looking at the pieces one by one and seeing how many points total would they have in one figure. So you want to check the right angles. Triangle has a right angle here, right? So that's 1 point. The square has 4 right angles, so that's 4 points, right? 1 point and 4 point. And that one is not a right angle, not a right angle, not a right angle, not a right angle, so no right angles for the other 2 shapes. Let's check a pair of parallel sides. Triangle doesn't have a pair of parallel sides. The square has 1 pair, 2 pairs of parallel sides. So 2 points each, which means 2 plus 2. So 4 points, right? And then the trapezoid has 1 pair of parallel sides, so finally it gets 2 points. And then the parallelogram has 2 pairs, so that's 4 points. Let's check for the shortest perimeter. So you have to count it. 1, 2, 3 units. 1, 2, so that's 3. 1, 2, 3, 4, 5, 6, 7, 8 units for the side. And then this is the hypotenuse, so you'd have to use the Pythagorean theorem. 3 squared plus 8 squared equals the hypotenuse, h squared. And so using the Pythagorean theorem, h is equal to square root of 9 plus 64, right? And then that's equal to square root of 73. So that's square root of 73. And that's gonna be between 8 and 9, right? The whole number. So you can approximately say, oh, 8 plus 3 plus something between 8 and 9 will give us about 20 as a parameter for the triangle. That's an estimation, okay? And then the area of the square, you don't know, you can't just count directly, so that's not 1 unit. It's the hypotenuse of this triangle, right? So you need to figure out the hypotenuse of the right triangle here, where the side is 3 by 3. And so let's do S for this one. So then S is equal to square root of 9 plus 9, which is 18. And square root of 18 is between, let's see, 4 times 4 is 16, and 5 times 5 is 25. So it's between 16 and it's closer to 4 then it's closer to 5. So square root of 18 is greater than 4, less than 5, but it's closer to 4. So 4 times 4 is 16, so maybe that's about 20 as well. To be exact, you have to use your calculator to multiply the square roots, okay? And then that one, 1, 2, 3, 4, 5, 6 units, 1, 2, 3, 4 units, and then that is, so if you draw another triangle, that's going to be 1 by 1, 2, 3. So let's say this is A. So A square is going to be 1 square plus 3 square. So A is equal to square root of 9 plus 1, 10. And square root of 10. So plus 6 plus 2 plus square root of 10, square root of 10. And then that one, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Those are parallel. And then you also have square root of 10 for the sides of this again, because the triangles are equal, right? So you'll figure out that this side is also square root of 10. So if you do the calculations, the trapezoid is actually going to get the shortest perimeter out of the whole shape. So the trapezoid gets 3 points. So trapezoid has 5 points, and then the triangle just has 1 point. The square has 4 plus 2 plus 2, that's 8 points. And then trapezoid is 5. And then the parallelogram will have 4 points, right? So compare 1 point by 8 points, by 5 points, by 4 points, and you'll see that the winner is easily the square. So let's record that and write that down in part A. Okay, I wrote it down on the side, on the left side here. The triangle gets 1 point from the right angle. The square gets 8 points by having right angles and parallel sides. The trapezoid gets 5 points by the parallel sides and the shortest perimeter. The parallelogram gets 4 points by getting parallel sides. And the square has the greatest total points because of that. Okay, let's look at part B. Describe a way to determine the perimeters that is different from the way you chose. Which method do you consider better? So this is the way I solve for the parameters, like using the Pythagorean theorem to solve for it. And then adding all the sides together. But what is another way that we could have used? You could have just used estimation like I did in the beginning, but if you used calculator afterwards, then you just use the Pythagorean theorem with the accuracy. So if you use estimation, you might not really know which one has the shortest one, because, you know, how do you know what exactly the square roots are? If you use estimation, maybe it was obvious that it was still obvious that trapezoid will have the least perimeter because square root 10 is obviously between 3 and 4, and it's closer to 3. So if you use 3 as an estimation, then the trapezoid would definitely get the shortest, the least perimeter. But still, that's still an estimate. So if the perimeters are super close to each other, then your estimation method doesn't really work. It might not really work, because if they're super close to each other, if the perimeters were super close, then depending on your estimation, the answers are different, right? It could probably have different answers. So using Pythagorean theorem is, I would say, the most accurate way. So we could just write that down. So we could say we use the Pythagorean theorem. We could have used estimation, but the Pythagorean theorem is more accurate. Okay, so let's think about the essential question for the lesson. How are properties of geometric figures represented in the coordinate plane? So we'll see different kinds of figures on the coordinate plane, and we'll be able to identify different parts, different information, depending on the information given. So this lesson is highly relying on Algebra 1 skills. So if you don't remember coordinates, please go back and review them. Let's look at example 1. Connect algebra and geometry through coordinates. Isn't that amazing? Math always comes back and connects with other concepts that you have learned. It's very logical. So you'll find beauty in that. What formulas can you use to identify properties of figures on the coordinate plane? So on the coordinate plane, you see a triangle, and the points are labeled for you. Point A is 1, 6. Point B is 3, 1. C is 8, 3. So part A, which formula can you use to find AB? So when they say AB without the line on top, that means the length of line AB, excuse me. So if you have, if you have a line AB, that is called line AB, okay? These are just notation stuff that you need to know. If there is no line and it's just AB, that is not representing the line AB. It represents the length of line AB, okay? Or line segment AB. So they're different. So if they say which formula can you use to find AB, it's talking about the length, right? AB. So you can use the distributive property or the Pythagorean theorem like we used in the previous example. So find a right triangle here, and you'll count the units and see that's 2 units, and 1, 2, 3, 4, 5. That's 5 units. So using the Pythagorean theorem, you can represent AB as AB squared is equal to 1, 2, 3, 4, 5. 5 squared plus 2 squared. Okay? But how do you figure out 5 and 2 if you are not allowed to just count it? You use the coordinate points. So 5 represents your y values, the differences of your y values of the points. So 6 minus 1 is 5. And then 2 represents your horizontal change from point A to B. So because you subtracted 6 minus 1, you have to start with A, 1 minus 3, okay? And we're talking about distance, so you can put an absolute value. 1 minus 3 is negative 2, but absolute value of that is positive 2, okay? So you'll see that AB is equal to square root of 25 plus 4, which is equal to square root 29. So we'll use a lot of Pythagorean theorems throughout this topic. So please write the Pythagorean theorem down if you don't remember it. It is a squared plus b squared equals c squared, where c is the hypotenuse, and then the other sides for a and b. All right, part B, what point bisects line AB? You're going to use the midpoint formula to find a segment bisector. The midpoint of AB is in the middle, right? But how do you find the midpoint? There is a midpoint formula that you learned in Algebra 1. If you don't remember, for any points, x sub 1 and y sub 1 and x sub 2 comma y sub 2, these are 2 points, and they just represent different values of x and different values of y. You can use the midpoint formula, x sub 1 plus x sub 2 divided by 2, comma, y sub 1 plus y sub 2 divided by 2 for the coordinate points. So you add the x and y values up and then divide it by 2. Okay, so 1 plus 3 divided by 2, 6 plus 1 divided by 2. Should be 2, 7.2, and if you plot that, it's right here, 2, 7 over 2. All right, part C, why do slopes of line AB and BC show that measure of angle ABC is 90 degrees? So first of all, do you remember the equation of the slope? We want to find the slope of line AB and line BC. And we want to see if this is right angle or not, okay? But how do you know? We learned that slopes of perpendicular lines are opposite reciprocals. So there are lots of algebra facts that you need to remember. Just an example 1. The Pythagorean theorem, the midpoint formula, the equation of the slopes, and the fact that perpendicular slopes are opposite reciprocals. Okay? The slope formula. Is m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay? So your numerator represents your change in y values, so your vertical change, and your denominator represents your horizontal change, okay? And that's why when you count the slope, when you're graphing an equation, you count up and down first because that represents a horizontal change. Okay, so slope of AB is 1 minus 6 divided by 3 minus 1, and that's equal to negative 5 over 2. So the slope for this line is negative 5 over 2. And the slope for BC is 3 minus 1 over 8 minus 3, and that's 2 over 5. So that's m equals 2 over 5. So compare these two slopes. Negative 5 over 2 is opposite reciprocal of 2 over 5. If the signs are flipped to positive from negative or to negative from positive, they are opposites. And if the fractions are flipped upside down, they are called reciprocals. So negative 5 over 2 and 2 over 5 are opposite reciprocals, which means these lines are perpendicular. So now you can prove that this angle is a right angle, okay? And if the product of the slopes is negative 1, if you multiply them and you get negative 1, that means they're opposite reciprocals and they're perpendicular. Okay, so example 1 is very important. This is all about conceptual understanding. See if you understand the concept and how to know how to connect algebra and geometry. So let's look at try number 1. Given triangle ABC in example 1, what is the length of the line segment connecting the midpoints of line AC and line BC? So now you want to find the midpoints of line AC and BC, right? And then you want to figure out the length of that line. So think about how you can figure it out. Hint, hint, you need to be able to label 2 points. You need to have at least 2 points in order to figure out the midpoints, and also in order to figure out the length, you need to use the Pythagorean theorem. So you need 2 sides in order to figure out another side, the third side. Okay, so please pause the video and see if you can try by yourself and come back when you're ready for answers. Okay, are you ready? So first of all, what's your first step? You want to ultimately find the line that connects the midpoints, right? So first, you need to figure out the midpoints as well. Let's use a different color. So midpoints for rich lines, AC and BC. So AC is here and BC is here. So that's my estimation of midpoint, but how do we know where it lies exactly? Right? Use your points and use the midpoint formula. So your midpoint formula says, using the points, you just add up the x values together, divide by 2, y values together, divide by 2. So 3 plus 8 divided by 2, comma 1 plus 3 divided by 2 is your midpoint, which is 11 over 2 and 4 over 2, which is 5.5, comma 2. Okay, so that's 5.5, comma 2, and that looks about right. And then look at this midpoint. It's going to be 1 plus 8 divided by 2, so that's 9 divided by 2, which is 4.5, right? And then 6 plus 9 divided by 2, so 9. 6 plus 9 is 9. 6 plus 3 is 9. 9 divided by 2 is 4.5 as well. So 4.5, 4.5 is another midpoint. So now we have the coordinate points for the midpoints, and we want to draw a segment that connects, right? And now we want to find the length of these midpoints, right? So then how do you figure that out? You want to figure out the horizontal and the vertical distances. See part A, okay? The differences between these 2 points for the x values and the y values are the side lengths, the horizontal and vertical side lengths of this triangle, this right triangle right here, okay? So horizontally, we're subtracting 5.5 and 4.5, and you get 1. Okay, that is 1. And then 5.2 minus 4.5, 2 minus 4.5, an absolute value of that is 2.5. Okay, so using Pythagorean theorem, can you figure out the hypotenuse? Yes, you can. So the length would be 1 square plus 2.5 square root the entire thing. And that we can say is called x, or let's do a. Okay, that's a. So a is equal to that, and then that's just 1 plus, what's 2.5 times 2.5, or 2.5 squared? 6.25. Just square root 7.25, and if you square root it, you will get 2.69258240356725, and so on. So we can just round it down, or we can just leave it as an exact solution right here. Square root of 7.25 is enough, okay? All right, that was quite a bit of an example. Let's move on to example 2. Classifying a triangle on the coordinate plane. Part A, is triangle XYZ equilateral, isosceles, or scalene? First of all, do you know these vocabulary words? Equilateral triangles are triangles that have all same sides. Isosceles have two sides that are equal to each other, which means, and it also has two angles on the bottom that are equal to each other. Scalene triangles don't have equal sides and don't have equal angles. Okay, so we want to figure out if this triangle is equilateral, isosceles, or scalene. Then what information do we need to solve for? We need to solve for the lengths and see if the lengths are the same, right? Using the Pythagorean theorem, you can use the differences of the horizontal and vertical distances to figure out the hypotenuse, which is going to be the side, one side for that, and then draw another right triangle. And if you use the differences of the vertical and horizontal distances by subtracting them, right? And that's the right triangle that you can use to figure out the hypotenuse using Pythagorean theorem, and also this one, okay? So using Pythagorean theorems and using the differences of the x and y values, you get these distances: square root 52, square root 13, square root 65 for each side, okay? So xy is square root 52, yz is square root 13, xz is square root 65. Are they the same? Those are all simplified already. So if you simplify and you don't see same numbers, then they're not the same answers. They're not the same values, right? So no two sides are congruent. This is a scalene triangle, okay? So part B is triangle XYZ, a right triangle. If triangle XYZ is a right triangle, then we have to be able to figure out a right angle, right? Then XZ is the hypotenuse because it's the longest side. And by definition, hypotenuse is the longest side of a right triangle. And so if you figure out, if you plug these numbers into the Pythagorean theorem and check if these are equal to each other, right? That square plus that square, is that equal to the longest side square? And if they're equal to each other, which they are, then yes, the triangle is a right triangle. So use the Pythagorean theorem to check and justify the right triangle.